Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. So today's topic is addressing modes of 8051. This video is a part of series microprocessors and microcontrollers. Coming to the overview of today's presentation. So what are addressing modes and how many addressing modes are there in 8051 microcontroller? Immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, and indexed addressing modes. So coming to the addressing modes. What are addressing modes? Addressing modes refers the way of how we are specifying the data in an instruction. So it is you all know that instruction is very important for the controllers to execute any such of applications, and these addressing modes define how the microcontroller fetches the data, whether it is fetching the data from the memory or from the registers, or we are giving the immediate values in the instruction itself. So addressing modes help the program to optimize an execution by providing flexibility in data access. So in 8051 microcontroller, there are 5 addressing modes. So the first addressing mode and it is fast when compared to the other addressing modes. That one is immediate addressing modes. So the name itself suggests that in the instruction, the immediate data or the raw data will be provided directly in the instruction itself. So here is the example of immediate addressing modes. Here if you saw, so here we are representing hash, which is nothing but that the data after this one is the raw data. So here in this particular instruction move, so the data will be copied from the destination register to the source register. Here A register accumulator will be copied with the data AFH. So why we are mentioning 0 before AF? Here in the next instruction, move R3, hash 45H, we didn't mention any 0 before the number. But here in this particular instruction, we have mentioned the 0 before A. Why? So while representing the hexadecimal numbers, we will represent the numbers from 0 to 9, and from 10 onwards, we will represent that number with the alphabetical order A to F. So to represent this A to F 10 to 15 numbers, we will be using A to F respectively. So if we are using any alphabets as a raw data, so we must specify that data before the data 0 will be included. If not, it will throw some error. So that's why I have been using 0 before the number. 0 before the number A and F, like 10 to 15, to represent 10 to 15. Here the data 45 is immediate data because we mentioned here hash. So this data will be moved to the R3 register. So as you all know that we are having A and B general purpose registers and R0 to R7 registers from bank 0 to bank 3. So 4 banks, each one is having 7 registers. So you can utilize all these registers from each bank separately. So here coming to the move DPTR. DPTR is a data pointer which is used to help access the data from the external memory. So as in the 8051 microcontroller, the memory will be in the internal memory. So to access internal memory, we will be using other registers. To access the external memory, so 8051 controller can access 64 KB of external memory. So to access that external memory, we need to have 16 address lines or 16-bit data will be. So in that case, we will be using DPTR to access that external memory. So that's why here I am giving 16-bit data or 16-bit raw data to be moved to the DPTR. So this is the examples of immediate addressing mode. Here in immediate addressing mode, the data will be accessed very fast since the data is loaded in the instruction itself. However, it is not that much flexible because while at compile time, it is not very much flexible. So Coming to the next addressing mode, it is a register addressing mode. The name itself suggests that the registers will be presented in the instruction itself. But here in this particular mode, the two operands like a destination operand and source operand should be of the registers. So you can use any register, depends upon the availability. So here in this particular instruction, the data present in the R4 register will be moved to the accumulator register or be copied. The data from R4 register will be copied to the A register. Here, if R4 register is having the data like 03H, suppose, assume that. So now after execution of this instruction, the A accumulator will also hold the 03H. It is not like a cut and paste, so it will be copied. So the R4 register is having the same data as well as the accumulator register will be having the same data after execution of the instruction itself. So here the data present in the A register will be moved to the R2 register, and in this particular instruction the data present in R5 register will be added to the data present in A register, and automatically the output will be saved in the destination register itself. Here A accumulator is the destination register. So the output after execution of this particular instruction, the output will be saved in the accumulator itself. So here one condition is there in this particular register addressing mode. Not only this addressing mode, every addressing mode need to be followed this particular rule. So what is that rule? Means the destination register, the size of the destination register will be matched with the size of the source register. Here in this case, let us see one example. So here move A comma DPTR. In this particular case, the DPTR is a 16-bit register. It will hold 16-bit data. But here accumulator A register is a 8-bit register. So how we can copy the 16-bit data to the 8-bit register? So it is not possible. So it will throw some error. So this instruction is not a valid instruction. So how we will move? How we will take 8 bits from the DPTR? So the DPTR can be written as DPH and DPL of 8-bit registers. So this 16-bit register of DPTR can be divided into DPTR higher byte and DPTR lower byte. So if you want to send the data in the DPTR register to other registers, so you can use DPL or DPH respectively. Right. So coming to the next one, here another one is there. So the data in this register, in this addressing mode, can be moved between accumulator and Rn registers. Rn means nothing but n equals to 0 to 7. That means you can transfer the data or you can manipulate the data in register with other R0 to R7 register. Any register you can use. But the thing is, you shouldn't use two Rn registers in one instruction. So here move R4 comma R7. These are internal registers. So you shouldn't use Rn registers in single instruction. Either in this particular case, you can use move A comma R7 or you can use move R4 comma R7. Sorry, R4 comma A. So suppose how to transfer the data or how to copy the data from the R7 register to R4 register. For this purpose, you can write the instruction like this. First, copy the data from R7 register into accumulator or B register. Now the data that R7 is holding will be copied to the A register. Now you can transfer that particular data to R4 register. So this is how you will write the instruction. This instruction is not a valid instruction because here in this particular instruction, two Rn registers have been using. No, it is not possible in microcontroller 8051. So instead of this, you can transfer the data to the one immediate register like A register or B register. So first you need to transfer the data to another register, and from that another register you could transfer the data to the destination register. Right? So coming to the next addressing mode, it is direct addressing mode. Yes, the direct addressing mode means the value to be stored in memory is obtained by directly retrieving it from the another memory location. So in this particular addressing mode, the instruction will hold the address of the the pointer to specify the data in the memory. Suppose in this particular instruction, move a comma 30h. Here I didn't mention any hash before 30. So it is not a raw data. So if we didn't mention anything, that particular thing will be considered as a address of a memory location. Suppose, so if we are having 2930. So suppose these are the address locations and these are the data present in that particular address location, right? So here what we are saying in this particular instruction, move a comma 30h. So this particular address will hold the data. That data will be moved to the A register. So here the data is 30. That 30h, after execution of this particular instruction, the A register will hold the data 03h. So the in the instruction itself, we have been implementing the address of the data. So here you can transfer the data from register to another address location also, another memory location also. Here that one is doing move 56h comma A. So in this 56h is a address of a memory location. So the data which is present in A, suppose here in this previous instruction, what is A holding? 03. So this particular 03h will be moved to the address location of 56h will be copied. So here 56h address memory will also hold the same data in the A register. So this is how we will be specifying it. Next, coming to move R4 comma 7FH. Yes, R4 registers, you can use R4 registers. R0 to R7 registers along with A and B registers can be used in this direct addressing mode. Coming to the next instruction. So here move A comma 4. So if we are seeing like this, it doesn't have H after 4. So it is not a address. So if we are specifying with H, it specifies that it is an address. But here you are not specifying with H. So it is the register. So instead of writing R4, you could write 4. So here move A comma 4 will be equivalent to move A comma R4. So 4 is nothing but the register R4. Instead of R4, you could use 4 also. So the data present in R4 register will be copied to the A register itself, right? Yeah. Now see here in this particular thing, what is the first instruction? Move R2 comma hash 8. So hash 8 5H means, so it is a raw data. That data will be moved to R2. So 0 5 will be moved to the R2. So R2 is having 05H. Next, move A comma 2. So what is this? A comma 2. 2 means it is a register. So the data present in R2 register will be copied to the A register also after execution. So move A comma 2 means A is equivalent to R2 register. What is the data present in R2 register? 05H. The same will be applied to the next instruction. So B equals to 05H. So this is how these addressing modes will work. Coming to the in this addressing mode, there is some rules and regulations we need to follow. In direct addressing mode, these addressing modes are generally fast, not more than the immediate addressing mode, but that is not flexible. Immediate addressing mode will work fast, but that is not flexible because at runtime, it is not flexible. So we are not giving the data. The data itself is given in the instruction itself. Here in this direct addressing mode, one of the biggest advantage is the data that is present internally in the 8051. So we are specifying the address location. So the controller could access that data from the internal memory much more faster when compared to the other addressing modes. And it is also much flexible that the address will be, the data will be stored in the memory. So you can read and write the data flexibly from the memory. So it is flexible also. So, and another one of the important thing is that when using direct addressing mode, refers to the address between, if we are referring the address between 00H and 7FH, it is referring the internal memory of 8051 microcontroller. So if we are specifying 00H and 7FH between these address locations, it will be directly locating to the internal memory of 8051 microcontroller. So if anyone doesn't know how it will be in the 8051, in the previous video I have already explained the memory organization of 8051, internal RAM and external RAM, internal ROM and external ROM. I have been already explained. So do check that video also. So coming to the next addressing mode, register indirect addressing mode. This register indirect addressing mode is very powerful addressing mode in 8051 microcontroller. So in this register addressing mode, we will be specifying the data will be specified as a pointer. So the data which we are providing in the address will hold the address location of the data. So here, if the data is inside CPU, only register R0 and R1 will be used. In this particular addressing mode, you shouldn't use R2 to R7 registers. No, you shouldn't use. You can use only R0 and R1. To specify a data indirectly, R0 and R1 registers will be used. So in this R0 and R1 registers, if you want to specify indirectly, you should use the sign @ symbol preceded by the @ symbol. So, coming to the examples of indirect addressing mode. Here, move A, @R0. So, if the R0 register is holding the data 03H, suppose, let us assume that. So, after execution of this particular instruction, what will be the output? What will be the data present in A registers? Let us see. So, here, if R0, we are specifying R0, it is indirectly saying that the data present in R0 is the address location of the data, actual data. So here, what is the data present in R0? It is 03H. So the controller will look into the 03H location. So here it is specifying the address. So this address location, one data will be there, like if you consider it as a 10H. So A register will be loaded with 10H. So we are indirectly specifying the data, not directly. So here R0 will hold the address of the actual location of the data. So this is how we will indirectly specify the data. In this particular one, R0 and R1 can be used as a pointer to which represent the internal RAM, because R0 and R1 it is a 8-bit register. So only internal memory can be accessed by using these particular registers. So if we want to access the external memory, so to access the external memory of 8051, we should have 16-bit. So in this particular in this particular application, to access the external memory, we will be using the DPTR, because DPTR is a 16-bit register. So we will be using DPTR to access the external memory location. So this is the register indirect addressing mode. Coming to the indexed addressing mode. This is one of the important one. So indexed addressing mode is used to get data from the lookups tables of 8051 ROM. So it is a code. Actually, see, in this particular instruction, A along with DPTR will form the address location. Suppose if the DPTR is holding 1032H and A is having 03. So now what will be the address location of the data, actual data? So the address location of the actual data will be provided by adding DPTR data with A. So after using this, so this is the address location where we can find the actual data. So in 1035 address location, so it is external data. So that's why we will be using DPTR. So that particular data will be moved to the or copied to the A register. It is fine. So I was telling address locations are 16-bit, but the data present in each and every address location will be of 8-bit. That's why that particular 8 bits of data will be copied to the A register. Okay, fine. Here if you observe that I have written move C, not just MOV. So move means it will copy. But what is C? So in this particular indexed addressing mode, we will be using this C. Why? Because here C is a code. So move C is used because the data is in the code memory, ROM, not RAM. So until now we will discussing the RAM locations, but this representing C means, so this data is from code memory. So we will be taking the data from the ROM locations. So here, if you see here, so after execution, what will be the data loaded in the DPTR? It will be 1234H. So here immediate data is given. So next here what it will be? A will be loaded with 56H. So now what will be the data moved to A? So first it will find the address of the particular indexed thing. So here 1234H and 560189. So this is the location of the data, address location of the data. So it will go to the 1290H address location, and the data present in that particular address location will be copied to the A register. So that address location usually find at ROM locations. That's why we've been using move C. Here in these two locations, in these two instructions, I didn't use C because they are RAM locations. Here we are specifically using because it is a ROM location. So these are until now we have discussed about the addressing modes, what are the addressing modes and why we've been using addressing modes, and how different types of addressing modes are accessed in 8051 microcontroller. Thank you.